Right. Salvorani. Welcome back. Guys, our time is running out. This is the second last time we're going to be hosting you at my time. Next weekend for the last time. Okay? It's been wonderful. I have enjoyed hosting you. I think some of you might have, I don't know if you can, did any of you come when you were 13? And then it was grade 11 and then the stuff. Right, guys, what today, and I keep trying different things. Okay, today for the first time, we've actually given you the resource for four. Okay, and I know I'm probably only around good afternoon. Very irritating because I paid extra money here to get it there quickly one day, and on Monday. Yeah. But I'm going to be about something like if you can give it to you, if you want to about for next weekend, the paper 2-1. You should have paper 1 and paper 2. Today we're going to paper 1. Next week we're going to paper 2. And then guys, as you know, your exam for both subjects are the week after that. Okay, the Friday and then the Monday. So we're ready to thank you. That's the anymore. Okay, so I'm hoping that some of you, at least, right, not all of you, I know it won't be all of you, have had a look at some of these questions. This exam here is an actual exam, okay? It was written it was written by our boys here. Now, sometimes you might say, oh, Paul, that's an IEP exam. The content, the curriculum, exactly the same. Okay. Any of these questions could be questions just like this could be in your exam. Okay. The first one, and I'm going to ask Mr. Babalega, guys, I really want decent levels of participation. I'm going to ask him to wander around and to take some questions. I want us to try and answer these questions together. Okay. I know how to do them. I promise you, I know how to do them. Mr. Babalega knows how to do them. We want to make sure that you guys are engaging. One of the important things about learning is that when you teach someone else, when you explain something to someone else, you understand it better yourself. When you help a friend, you are being more helpful to yourself, even with your maths, as much as you are being helpful to them. Right, let me kick off. If you're confident about doing this question, maybe just put your hand up, okay? And don't be scared. One of the things we want to develop in you, as much as your maths, we want to develop self-confidence as well. All right. We also want you to always do the right thing. You know that. Okay. I see you guys. There's never a right time to do the wrong thing. Okay, guys, I'm looking for someone wanting to do the right thing. This is not a difficult question. This is a 2-mark question. Okay, and if you write nothing, how many marks are you going to get? 0. Okay, we don't want to get 0 for the first question. To jump to the last page. Okay. Anybody come, guys? We've got to do something.
Everyone. That's where I think will equation into a standard form.
Well done. Hello. Okay. Guys, this is the quadratic equation. Well done. All right, carry on. Okay, we're going to try and factorize it. I'm going to ask you, keep the mic, okay, because we're going to keep talking to one another. I'm enjoying it. I hope you're enjoying it. Okay, if this sign is a negative, what can you tell me about these two signs that I need to put in the bracket here? They will be different. Well done. One of them must be plus, one of them must be minus. I'm actually asking my friend with the microphone. Do you have any idea what these must be, my friend with the microphone? What are they?
Must be split into but statement, take.
Well done. Okay, very nice. Guys, you see, there's two things. He's given me the right answer, but he's actually explained some of the thinking behind it. This product must come out negative. So the bigger number must have the negative. Okay, just tell me your final answers for this question.
Okay, so F is equals to 3 or
Minus 2, yeah. Okay, right. Hala. Okay, guys, we've done 2 marks. We've got 148 to go. Right. Okay. In the exam, guys, if you do 1 mark per minute, you will have half an hour extra at the end. Okay, so when you see a question for 2 marks, say to yourself, can I try and do that question in 2 minutes? Okay, Manje, Nancy King, we've got a problem, we've got fractions. Don't be scared. Anybody want to tell me how we're going to get rid of these fractions? Right down the front here, Mr. Mabalek is going to get lots of steps for his vitality points today because he's going to walk. But just now we're going to swap, we're going to shincha, and then Mr. Mabalek is, I'll get my steps up. Right here in the front corner. Now, yeah.
It's 8 plus 1 equals 8 minus 3.
Okay. I'm wondering whether you're going to add these fractions or whether you're going to get rid of the fractions. Yeah. So what we're going to do? We're going to multiply every term on both sides by what you told us there. Remember the idea of an equation? It's like a balance. Okay. Whatever we do to the one side, we must do to the other. What will we get if we do that?
Okay. In 3 plus 2. Bracket equals 10. And over the table.
Yeah.
Minus 3.
Yeah.
Open bracket 8 plus 1.
No, yeah.
Over.
Okay. Yeah. All right. I know what you're doing now. I will do it, but I'm going to show you that it actually is not really necessary. Okay. You're doing all over x plus 1. Okay. And on the right hand side. Yeah. It won't. Okay. I see what you're doing. Okay. All right. Okay, Margie. Yeah. Yeah. So yeah, keep going. Okay. All right. And then what did you do after that? Okay. So you're not wrong. Okay. I don't like these fractions. I don't like fractions when I'm solving an equation. So what I would have done if I were you, I would have multiplied both sides by this. Okay. You did it at the end. Okay, that's fine. I would have done it sooner because you don't need the denominator. Okay. What did you get once you had done that, if you don't mind my asking?
Into 8 plus 1.
Yeah.
Into 8 minus 3 minus 3 8 minus 7. Equal to 8 squared minus 1 8 minus 2.
Okay. I think it's like that. I might be wrong. I'm getting a little bit nervous here because I'm not doing it how I would have done it. But anyway, let's keep trying. Okay, so I think it will be x squared. You see this blue piece? I like this blue piece. It's exactly right, and it comes to x squared minus 3x minus 7. Okay, on the right-hand side, if I multiply this fraction here by x plus 1, x minus 2. Sorry. If I multiply it by x plus 1, x minus 2, and that stuff's over 1, what would be left here on the right-hand side? Just x minus 2. Okay, all right. So you're not wrong at all. I'm going to be very interested to ask you at the end whether you got the answers that I'm going to get. What I'm saying to you is that I think we could have gone straight here and not had the denominators. Do you see what I'm saying? Okay, all right. Let's carry on from here. So it's going to be x. It's going to be x squared minus 4x. That's 3x, and take away that x minus. Well done, minus 5. Let's quickly factorize that. So we're running out of space here a little bit, but x and yeah. X plus 1, x minus 5. So what are our answers? X equals minus 1 or 5. Okay, are we finished? Are those the answers you got? Well done. Okay, but now Nancy thinking, all right, guys, are both of those solutions okay? And I want you to look up at the top. If we look at this question, I want you to look at the denominators, because in this question, right from the beginning, we've got a big kind of warning flag. X cannot be minus 1 and x cannot be 2. Right. If x is minus 1, Norma, x is 2, that's a key. Okay. So what's our final answer to this question? 5 only. Okay. All right. Thank you very much. Okay. I'm looking for some help with this next one. It's an inequality. And guys, you might not know how to get the answer. It's 4 marks. If you don't do anything, you're going to get 0 marks. All right. We need you to try and make a start. I'm looking for a volunteer here. We've had 2 excellent volunteers so far. So guys, I'm just trying to check. Anybody, that's something we can do. Yeah, here we go.
So the first thing we're going to do is, sway the eggs.
Yeah. Just tell me what to ask, right? So guys. Okay. Wait, my man. Guys, while I talk about that, can I just say the night before your exam, go to bed early. If you don't go to bed early, like last night, I didn't go to bed early. I was doing some work till late, and then you do silly stuff. Yeah. X squared over. Yeah. Yeah. Okay. You want it? Okay. Oh my goodness. It's a little thing. It's a very little thing. This term transpose, and I know lots of teachers use it. You've heard me say, what are we going to do? We're going to add 3 to which side? To both sides. You're absolutely right. It is transposing it. I prefer the language of add 3, but it's fine. Okay. Correct? Yeah. Yeah. Halala. Yeah. Okay, so we're going to factorize it, huh? Yeah. Yeah. You carry on.
So.
Yeah.
And then you draw it.
Okay.
It's simply on the same form. Yeah, the coefficient of x squared is a coefficient.
Yes.
So in this case.
Was that called concave? Ah, yeah. Well done. Yeah. La la.
So. We creative. Vision. Beyond.
Well done. Yeah.
So. It's going to. But 11.
Can you tell me how I'm going to write that using inequalities? I mean, I know I can write it like this. Round brackets, huh?
Yes.
Or square brackets?
Whatever.
Square bracket. Well done. How would I write that using these things?
Excellent.
Yeah, well done. X in the middle. Well done. Yeah.
And.
And halala. Uyi mobile. Well done. Okay. Very nice. Okay. Let's go here. This is a simultaneous. That's what the Americans say. Simultaneous equations. Right. Who can tell us how we get started here? Here we go. We've got someone. Okay. We've got someone there. Okay. Far away. Someone.
Yeah. La pan. Pretty manual is only air spread, it's like 24. If you put it in two into the air, my mom, right, 24. To see it up. That's what it's on Christian food. You better put it there with Christian, the air to my own. That's what I find it, which the air, things unfortunately, but in making it why it's quite a new form, and that's the air. But when you make it to wind up on. I mean, no, I was making it for that's the air. The equation data. Quindi per l'integration one, lo x squared plus x y equals 24. As one of the new lines, y was like negative 4 plus x so far x squared plus x equals negative 4 plus x equals 24.
So. Yeah, carry on.
Negative 4x plus 3x squared equals 24. The more, yeah, the one minus 7 over squared plus. Because of 4x squared minus 4x equals 24. Finally, I really just like divide down 4 the maximum 75 over the and plus so that what I'm going to divide there 4 and x squared minus x minus 3. expanding, forever, or expensive, whatever effective or whatever it is. I think that I was expanding by something whole, but I think, we really can live through my own side, but for.
I'm trying to follow the Zulu and I'm sort of managing, yeah. What did you get for your X? Sorry.
It's really, among other, as is what makes it. Trabalhar com ela, uma questão de fazer que trabalhar com dificuldade e perder for literally including components for.
Wouldn't this one be easier? You're right, but wouldn't this one be easier? What do we get for Y? And for Y here? Allah. Well done, my friend. I tell you, I'm very pleased that you think my isiZulu is so good because I need go and think. Okay, well done. Okay. Like Allah, we've got some people coming out. Where did you Puma from Brandville? Where did you come from? Brandville Primary. Michelle O'Connor. Okay. Guys, welcome. I'm sorry. Yeah, you can sit. You know what? You can sit. You can even sit in the very front row if you want, or you can. Yeah. Okay. You can. Okay. Guys, I don't want you to sit. Don't sit right in the back, guys, because it's very dark. Yeah, I think we just. That's fine. You can sit in row number 2 here, because Mr. Mabaleko or myself can reach forward to you or backwards from the rows. So come down to the front here, guys. Come to that row. And you can also come. You can come right around the front. If it's full that row, you can come right around the front and come in this side. Okay, we've just made a start quite recently. Yeah, so those people these guys now, yeah. Come around here. Come right around the front. And come in this side over here. Okay. I don't know if we're still waiting for anyone else. So who was on that taxi? Just Shane O'Connor Leonard. Okay. Man, you want to grab the microphone? Very quiet. We are slightly late, but better late than never. If you can, you have. There we go. We've got some visitors there. Nice to see you. Namkele Kile. Siyajabula ukunibona la. And welcome. I'm hoping you can hear us nice and clearly. I am going to mute. I see you guys are from Mzwandile Mbongwe High School. I am going to just mute you guys because we're hearing you at this side. Okay. Right. Anybody got some ideas for us here, guys? Oh, okay. I thought we had the microphone in someone's hand. No. All right, guys, I'm going to make a start with it. What I'm seeing here, it's asking me to basically to solve it for, but I'm going to have K in my solution. What I'm seeing this is the same. So what I'm going to do is I'm going to subtract the right-hand term from both sides. When we've got X in two places, there's a trick. Yeah, no, that's right. Sorry. Okay. Can I take out a common factor here? What is the common factor? Well done. X minus 1 over K. And what will I have in the bracket if I have X minus 1 over K? X minus K. Well done. All right. Now, guys, do you now see that this is the standard quadratic equation with a multiplier and a 0? So what must X be? What must X be to make this bracket 0? 1 over K. Norma, what must X be to make this bracket 0? 2K. All right. That's, yeah, I think that's quite tricky. It's different. Okay. It's a little bit scary because it looks different because we got K. All right. Now it says, when will the roots be equal? Now, one of the roots is 1 over K and the other root is K. So let's make them equal. Now we're trying to solve this little equation. What can I do to both sides to solve this equation? Times by K, good idea. We've got rid of the fractions. What's my final answer? Well done. Don't forget that it can be plus or minus 1. All right. The safer thing is actually to go from here and to do that and then to factorize it. And we get K plus 1, K minus 1, and we get K equals minus 1 or plus 1. Okay. You can go straight here, but I can tell you the danger with going straight here, lots of people are going to forget to do that. Right, guys, 21 out of 50 marks. Okay, we're going to be fine for time, I'm hoping. Now, I'm hoping you've all tried this question. Okay, I'm looking for someone who can tell us how to do this question and see if you can get 5 marks for it. Okay, because, yeah, all right. Okay. Coming out the mark. No, yes.
Sorry about this. Sorry for this.
Okay.
So we had a question, as we started to explain that.
Okay.
The mathematical question, by the formula, where if X is equal to X at H. Yes.
No, sorry. Am I wrong or right? Good. This is you talking, I'll yeah. Yeah.
Or formula and from X is equal to and it's X plus H. Minus X.
Yeah.
So it's so let's say as as a
So you see that square, remember what A plus H means? It means put X plus H where all the X's are. So tell me what you think we're getting to the start here.
so let's say
Right? 150. So the, yeah, okay. Well done.
and then so it's
Well done. Okay. Don't get early minus one. If you put plus one in the bracket. Okay. Well done. You're doing well. And don't be nervous with the camera on you. I'm not gonna put it on YouTube or Instagram, okay? I'm not doing it my good. Okay? Enough.
so it's yeah. It
Okay. So I got a contract you said. Sorry guys, I'm gonna go here. No, no, that's not great. Minus or plus. Yeah. You're right. I prefer the word divide, okay? Yeah, okay. Just for it. Okay, all right. Guys, just remember, if you write this line, and you don't need to write this line, but if you write this line, watch what I'm writing here. I'm writing the last line again. If you do this, mark unfortunately, you can tell me why we didn't do the mark. Guys, if you run it like this, you have to put bracket because that limit is applied to the whole expression, not just to the 4x. Okay, right. Now, these marks I'm hoping you guys are going to do really well on. I'm looking for some answers here. I'm also hoping where's Mr. Mamalega? Yeah, find someone, and if you can just take a little bit of video every now and again. And when you're taking the video, you can swap between come around the front of the learner so you can see their face. You can swap between the screen and the learner and me, just a little bit. Okay, we won't do it all day, I promise. Yeah, carry on. Albert. Talk nice and loudly. Yeah. Sorry, yeah. Yeah. Finished. Okay. I'm going to mark it for you. You've got 2 out of 3. Well done. But why have you got 2 out of 3? Because you haven't told us what this is. This is not Y anymore. Okay. Absolutely. We need to give this a name. We need to tell the person marking our script that this is y prime norma dy dx. Okay. All right. But we're very well done. Okay. I'm looking for an answer for the next one. I do. Yeah, let's go to this one. Melbourne. So what's this? Yeah, Mann Street. Sorry, yeah. Square root of a half. So what? No? Negative a half. Sorry. Okay. Very, very nicely explained. Now, this last step, the positive exponents, it's a good idea. All right. This question specifies it. If this line wasn't here, they probably won't penalize you if you stop here. But it's safer. And in this question, it's requested. It's absolutely needed. Okay, we'll find that. All right. Now, here's an interesting question. We want to find the equation of a tangent to this curve, which is perpendicular to this line. 5 marks. Remember, if we do nothing, we're going to get nothing. We have a volunteer. Wonderful. I thought maybe no one was going to answer this one.
1 plus x plus 4. Okay, that we should what we spread that is 1 plus x equal to 4 instead of 4.
Good idea. Well, then he subtracted x from both sides. Yeah. Yeah. Well done.
Then we can get the present of this land is 1 the equation of the assignment is equal to data. Therefore, the value the product of the value of the assignment and the value of the expensive assignment is 1. Then, by doing this, we can get the value of the sentence. So, every sentence is that. And what's it's 1 answer that the person is valid, but it's and the regarding of the sign it will also.
Well done. Okay. Brilliant. So we've got a, yeah, carry on. Carry on.
One day of the now regarding bodies now what the value of since the equation of the sun also I should have a minutes for example 1 plus x plus 4 x and then I should be around then equals u1 x equals to so x plus 4 and then you're gonna substitute the we're substituted right here of the timing, which is equal to 4. Carrying of the timing, okay. So we will also so that's 4. The sum of it. Minus by 4 equals.
Okay. Sorry. Minus 2, sorry. Yeah.
Is 4 to the of C.
Okay, you're right. Carry on. Tell me what to write. So I'm writing ahead. So.
Total is 4. Okay.
No, you carry on. You carry on. Yeah.
Okay. One
La. Brilliant. Okay. Because yeah, this is a harder question. All right. It's a harder question because we don't know this point of contact. What we know, and it's a whole lot of like detective work, okay? We know the gradient of the line, and then we've got to get the perpendicular gradient. And then we've got to work out, and this is really important, we've got to work out not what is the gradient at 2, but where is the gradient to? And we found out that the gradient is 2 at -1, and then we can substitute in to get the y value, and from there it's fairly straightforward, but well done. Brilliant. Okay. Right. Inverse function. You can remind us how we find an inverse function. I'm going to tell you something here, that if I put 5/3 into this thing, I'm going to get log base 2/3. What's 5/3 -1, guys? 5/3 -1 is 2/3. Who can tell me what is log base 2/3 of 2/3? What power must I put onto 2/3 to get 2/3? 1. Okay. The only reason I'm doing that, I'm just doing that for fun, because I want us to see when someone gives me an answer, I'm going to check that if I put 1 into their answer, I must get 5/3 out, because remember, that's what an inverse does. Okay, right, let's go. I need some help. No one, anyone? I'm going to give you a start. The first thing we do, instead of writing f of x, we write y equals log base 2/3 x minus 1. What's one of the important ideas about finding an inverse? We swap x and y. And guys, the reason I'm swapping x and y, look here. This is x, this is y, this is x, this is y. Now I want to get y on its own. Who can tell me how to take this equation out of log form and into exponent form? Guys, I'm going to say something here. The base is always the base. So 2/3 what power to the x is equal to what? Y minus 1. So what is y equal to? Y equals 2/3 to the x, what? Plus 1. Okay. The last thing it did say is I must write my answer in the form f inverse of x. So my answer is actually going to be 2/3 to the x plus 1. I'm just going to highlight that answer pink. All right, just so we can make sure that we can see that is our answer. All right, let's just check, guys. If I let x equal 1 in this, what do I get? I get 5/3. Allah. And 5/3 is exactly what I need to get. Okay, now we're going to draw this graph, the inverse graph. This is an exponential graph. Who can tell me about an exponential graph when the base is less than 1? Does it go uphill or downhill? Guys, exponential graphs go downhill when the base is less than 1. That would be the basic shape. What does plus 1 do to the graph? It shifts it up. What will the asymptote be? I want the equation of the asymptote. Well, then y equals 1, not 1, y equals 1. Here's the asymptote. Now, this graph's going to do something like this. It's going to kind of go uphill. At some point, it's going to hit the y-axis. How do I find out where any graph hits a y-axis? Make x equal to 0. What do I get for y if x is equal to 0? 2. Well done. All right. I might, just for accuracy's sake, I might put in another point here. When I put 1 in, I've already worked out 5 1/3. Sorry, 5/3. 5/3 is 1 2/3. It's, sorry, 5/3. What? What's going on here? Oh, sorry. When I put. Oh, of course. It's going downhill. When I put 1 in, I get that. Okay. When I put, let's put in, and you can use your calculator. If you put -1 in, it's in fact we won't use our calculator. Let's do this. If I put -1 in, you can tell me what does this fraction become if I put -1 in? It becomes 3/2 plus 1. What's 3/2 plus 1? 2.5. Okay, guys, this graph is going to look something like this. Sorry, man. Sorry. You're absolutely right. It is 2.5. No, that's right. 2.5. Yeah. Okay. 5/2. Okay. All right. I'm just looking ahead because I want to forewarn Mr. Babalega that he's going to be coming up to do some work just now. Question 5, Mr. Babalega, if you can start looking at it. I'm going to ask you when we get to question 5 to take over, to give me a little break. Okay. Guys, what sort of equation is this? What's its name? Hyperbola. Okay. They're asking us to find A and B. This hyperbola has been shifted. Who can tell me in English, not in isiZulu and not in maths? Who can tell me in English, how has this graph been shifted? You can just put your hand up and you can just shout it out for us. Yes, over here. To the left by how much? Left 1 and, well done, up by 3. Allah, Allah. Okay, 1 left and up by 3. Can you tell me what must A be if we want to shift it 1 left? A must equal 1. And what must B be if we want to shift it 3 up? B is 3. Well done. Okay. Then it says the function has 2 axes of symmetry. Find the equation of the one that has a negative gradient. So guys, what I'm looking for this here, and I'm going to show you 2 ideas as to how we can find this. I'm looking for this. So I'm trying to draw it nicely. Okay, it looks something like that. Guys, it will always go through this point over here. You can tell me what's the name of this point? Give the x value first. What's the gradient of this line? Is it positive or negative? Yeah, guys, it's always either 1 or negative 1. Okay, this one over here, the other axis of symmetry has got a positive gradient, but they're not asking for that one. Okay. Can we find the equation of a line if we've got a point and a gradient? Easy, okay? The method I like to use, and I know it's probably not the method you like to use, I like to use this method. It's slightly quicker. Y minus the y value is equal to the gradient x minus the x value. And I get y equals negative x. This is plus 1, plus 3. I get negative x plus 4. Okay, I'm not sure if I'm right, but I think I'm not right. I'm definitely not right. Sorry, guys, this is y minus 3. Sorry, this is x minus 1, so it's x plus 1. So this is minus 1 plus 3. It's actually plus 2. And if I go and look here, guys, this is 2 over here. All right. I want to show you a different way of doing it without using this point. Vanilla. Yes, vanilla. Okay. The vanilla when we've got y equals k over x, the vanilla, okay, and it doesn't matter if that y equals k over x or this y equals k over x, which is like the one we're dealing with here. Both of them, the gradients, sorry, the axes of symmetry are y equals minus x. And the other one is y equals plus x. Let's put y equals plus x. Good one. When that graph moves, the axes of symmetry will also move. So I want to take this axis of symmetry and I want to move it the same way that the graph moved. And my friend over here told me that the graph moved left by 1 and up by 3. So what I'm going to do? I'm going to, how do I move it left by 1? What do I do to the x? I plus 1. How do I move it up by 3? I plus 3. This equation here, negative x minus 1 plus 3, negative x plus 2. Different way of doing it, same answer. Okay. Now, as they want the domain at the range of G. Now, let's have a look. What will the domain be? Is there anything x can't be? X can't be what? Well done. Let's do the range. Y can be anything, Kodwa. Y is not equal to 3. Halala. Okay. Question 4, my last question, and then I'm going to ask Mr. Mabaleka to have a go. All right. We've got this rather interesting graph with all sorts going on here. Okay. And the first question says, what's the equation of the asymptote of f? This line here. Guys, what sort of graph is f? You need it. Is it a parabola? Is it a straight line? What is it? Well done. It's an exponential graph. Okay. Now, let's look at the equation of it. What will the equation, how's this graph been moved? Firstly, guys, before we even talk about moving it, what does that positive 2, what does 2 tell us about an exponential graph? Is it going to go uphill or downhill? Uphill. And we can see it. There it is. It's going uphill. What does the minus 8 do? Shifts it down by 8. What is the equation of this asymptote? Y equals negative 8. Okay, it's only a 1 mark question. There it is. Y equals negative 8. How will I find the coordinates of this point? This point is a what sort of intercept? Y-intercept. How do I find the y-intercept of any graph? Let x equal to 0. Well done. Okay. Let x equal 0. So y equals 2 to the 0 minus 8. What is it? Allah. Careful here. Don't stop there because they want coordinates. What is the coordinates of B? Allah. 0 and negative 7. Okay. Now, where is C? Let's go and see. C is which sort of point? X-intercept. How do I find the x-intercept of every single function? Make y equal to 0. So I've got y equals 2 to the x minus 8. I'm going to make y equal to 0 equals 2 to the x minus 8 exponential equation. Okay, not a bad one. Let's add 8 to which side? Both. Allah. Can someone tell me what is 8 the same as? 2 to the power 3 is 2 to the power of x. X equals 3. Again, don't forget to write the coordinates of C. 3 and 0. Okay. Then it says find the values of A, P, and Q. Now look at this parabola. A normal parabola is ax squared. What does this do? It moves it left or right or up or down? Left, right? and this one here moves it up or down. This parabola, and I'm going to draw ax squared for you guys. I'm going to draw the happy version of ax squared. It looks something like this. This one, how has it moved to go from here to looking like this? Remembering that this is 3. How's it moved? 3 to the right. Has it moved up and down? No, it hasn't moved up and down. So what will P be? Careful, we want to move it to the right. Eh? -3. What will Q be? 0, because we're not moving it up and down. Now, how are we going to find the value for A? We're going to substitute a point. So what we know, guys, what we know is our equation is looking like this so far. Ax -3 squared plus 0. That's our equation. Now, we need to put a point into here. If I put this point C, which is 3, 0, can I work it out? Guys, unfortunately, I can't. If I put 3 in here and 0 in here, I get 0 equals 0. Which point must I use? I must use point A. Can someone just, I can't see it. Can someone remind me what's the coordinates of A? 4.5. What? No? Yeah, 4.5. Okay. I don't like mixed numbers. I'm going to write 4.5 as 9/2. X is what? 0. So this inside is going to be -3. Okay. So 9/2 equals 9A. What must I do to both sides? Divide by 2. I get A equals. Divide by 9. I'm going to divide by 9. What do I get? I get a 1/2. Okay. Good idea, guys, to make sure that your answers are nice and easy for the examiner to find. Okay. All right. Did we expect A to be positive for this parabola? Yes. When we looked at it, we said, ujabula. It's a happy parabola, okay? Or it's a concave up. Like a cup. Okay, concave up like a cup. All right. Now, if we take this graph, which we've got, how must I move this graph to get this graph? Inwards. I must shift it 3 to the left, because I'm going to actually take it back to the vanilla one that I drew up at the top here. This little red one. Okay. All right. Okay. Then it says, how is the domain of our of our function restricted if our inverse becomes that? Okay. Now, I'm going to show you 2 ideas. I think this is tricky. All right. Can anyone tell me what will the range of this be? The range of this inverse. What sort of y values will I get out? Guys, we'll only get negative values out. We will get y less than or equal to 0. Now, that means, all right, that means that's the range of the inverse. That means that the answer for the domain will be x less than or equal to 0. That's the answer. I'm going to show you the picture here, all right? If we draw the inverse, okay, yeah, okay, we actually haven't got the picture. I can draw the picture here. Yeah, so h of x is half x squared. Here's h of x. I'm drawing a bit nicer. Here's h of x. Remember, guys, and I'm gonna quickly find. I hope I can find it quickly. I'm gonna find a sketch to show you guys about inverse functions, just to remind you. Sorry, guys, I'm not finding it. And so I'll tell you what I'm going to do. I'm going to draw it because it's actually going to be easier to draw it. All right, have a look at this. I'm going to draw a function, f of x equals, I'm just going to go something quite weird, like x cubed, okay? Maybe x cubed plus 3. All right, now I'm going to draw another function, which is the inverse, x equals f of y. All right, who can tell me the relationship between those two graphs in terms of the how are they reflected? They're reflected about the line y equals x. All right, and I'm hoping that you can see that reflection. What I'm going to do now, I'm going to just make this one a different color. I'm going to make this one red. And I'm going to make this one over here blue. Okay, I'm going to show you something here. I'm going to take the red one and I'm going to move it. And I want you to watch what happens to the blue one. Do you see the reflection? Okay, so when we find the inverse of a function, we get a reflection in the line y equals x. So when I'm looking at this, here's the line y equals x. Now, when we reflect a happy parabola on its side, sorry, over the line y equals x, this piece here will go like that, right? Okay, and then it'll go over there somewhere. This piece here will come down here somewhere. This piece here is reflecting that piece there. Now, what that is the blue thing a function, guys? Is it one? Is it when we put in an x, do we only get one y? Is it a function? Yes, it passes the vertical line test. Is the green thing a function? No. Now, what we can do to the blue thing, we can restrict the domain. We could say, let's just take half of the parabola. If we only take half of the parabola, if I scratch this piece out, this piece here will go. Okay, but in this question, they didn't scratch that piece out. They said that the range, let's just read it again. And so they said that the inverse is negative root 2x. So this graph over here is actually y equals negative root 2x. This piece on top here is positive root 2x. We're not going to use this piece. We're going to scratch this piece. And if we scratch this piece, okay, then this piece must also scratch. All right. And it's not wanting to scratch. Sometimes they decide it will scratch and sometimes it won't scratch. Okay. Right. But guys, well, unfortunately, I've lost my blue piece. My blue piece was over here somewhere. And you see the domain. So this is the inverse. And this is the the function of h. What's the domain of the function of h? It's x less than or equal to 0. Okay. Now, look at this. What is this plus p going to do to our graph of f of x? Vertical or horizontal? Vertical. Okay. At the moment, does our graph of f, and I'm just going to highlight it for you, does our graph of f have any x-intercepts at the moment? Any roots? Does it cut the x-axis at the moment? Of course it does. Now, how much must I shift it? And must I shift it up or down so that it doesn't cut the x-axis? Up by how much? More than 8. If I pick this graph up by more than 8, it will end up somewhere here. Will it cut the x-axis? No. Okay, so P is bigger than 8. Right. Okay, I'm going to ask Mr. Mamaleka if you can come and take over from me, because as you can hear from my voice, it is breaking. Okay. All right, guys. Okay, guys, I'm really keen to get some engagement again. I've done quite a lot of work on my own now. I think sequences and series is something you got right. We've got 15 minutes, guys. Still we have a tea break. Oh, it's siren. And in 15 minutes, I'm going to stop for tea break. Just to help you with your energy levels, I'm going to walk around quietly and give you sleep or people. Okay. But I should have told you because now people are not. Okay. Yeah.
Okay, really?
Okay, so we're looking at question 5A. Right? They're telling us that we need to determine or find the value of k given that sequence. Okay. Now it's telling us that 3k plus 1, k plus 5, 2k minus 3 are the first differences of a quadratic sequence. Okay, so what do we know about the first differences of a quadratic sequence? Have they? Have they? They have a common what? Constant difference, right? Okay. So we're gonna do is, okay, so we know this is term 1, okay, this is term 2, and this is term 3. Okay, so if I say term 2 minus term 1, that should equals to term 3 minus what? Minus term 2. Okay. Now term 2 is k plus 5 minus 3k plus 1. That's equals to 2k minus 3 minus k plus 5. Okay, just be careful with it. Yeah, be careful with these negative signs, right? You need to make sure the term, so this term must be in brackets so that you can distribute the negative sign, and this term must also be in brackets so that you can distribute the negative sign. Okay, so how do I move on from here? Yeah, simplify, right? Okay, so k plus 5 minus 3k minus 1 is equals to 2k minus 3 minus k minus 5. Okay. Collect items, okay? Yeah, so how do you, yeah, I'm gonna take the case to the other side and I'm gonna take the numbers to this side. So I have 5 minus 1 plus 3 plus 5 is equals to 2k minus k plus, oh, sorry, excuse my writing, plus 3k minus what? Minus k. Now this gives me, so 5 minus 1 plus 3 plus 5 gives me 12. Is it 12? Yes. 12. Okay, so 12 is equals to, and this simplifies to, it simplifies to what? 3k. To find the value of k, I need to divide both sides by. Let's read, therefore, k is equals to here. Oh, sorry.
So the quiz on the 20. The bracket is top.
Okay.
20. Not. But. Other than you have many figures. Yes, so very good. Because the first of the I'm not really looking for someone to really question just that particular. So I'm looking for that. Yeah, I have I'm going to ask Ben Lynn on any of the all right, again, we've got to have a tool. Come on, shit. Oh, you want to get it done? Yeah, don't worry.
They still got the fire.
Yeah, we can count the number of matchsticks in each figure, right? Okay, so in figure 1 we have, it's okay, 4, okay, figure 2, 10, and figure 3, 13, and figure 4 is 18. Okay, figure 3 is 18. Oh, sorry. How do I go back? Oh, okay, it's 18, 28. Okay, so this is my sequence, eh? How do you know it's a quadratic sequence? Sorry? So we don't have, okay, we don't have a constant difference. Okay, so if you check for the first differences, okay, this is 6, and this is 8, and this is 10. Okay. Okay, so now if we find the what? If you look at the differences between the first differences, we have 2 and 2. Okay, so this is a quadratic sequence. Okay. Okay. Okay, so the nth term, okay, so give me the general formula of the nth term is equals to, beautiful. Okay, beautiful. Okay. So, okay, let's find the value of A. So A is equals to, sorry? So 2A is equals to 2. Therefore, A is equals to 1. Short. Yes. So 3A plus B is equals to It's the 6 because of the first tab of the first two. Okay. So 3 times 1 plus b is equals to 6. So okay, subtract 3 from both sides. So b is equals to 3. Okay. Okay. So a plus b plus c is equals to 4. Okay. Okay, so a is 1, b is 3 plus c is equals to 4. Therefore, the value of c is 0. Okay, now what is the, so Tn, so what's the nth term? N squared plus 3n. Yeah, that's it, right? Yeah, thank you.
Right, very nice answer. Okay. Carry on. You can use the mouse to scroll.
Oh.
Scroll there.
That's much.
Yeah, I've done that. Yeah. While. Sorry, no. You okay to do this one?
Yeah.
Okay, well, good. So guys, this register, I haven't got a school and I'm thinking maybe it is. So get it, you'll see more of it, and we'll wait for time. Yes, thank you.
Okay, so let's read the scenario. So Matthew borrows 30,000, right? Which he repays with monthly payments over what? Over 5 years, starting 1 month from the date of the loan. So the interest is charged at what? At 10% per annum, compounded monthly. Okay. So the first question is to determine his what? To determine his monthly repayments. So are we dealing with a future value calculation or a present value calculation? So it's a present value calculation. Okay, so give us. Okay, so give us. Okay, so it's trying to find. I'm gonna say. So P is equals to X. So 1, sorry, minus plus I to raise to the negative n. Okay, close this. Divided by what? Divided by I. Okay. Okay, so in this formula, what are we looking for? We're looking for? We're looking for the value of X, right? It's monthly repayments. Okay. Okay. So the present value is 30,000. Okay. So X, okay, 1 minus 1 plus, okay. So 0.1 divided by what? Why are you dividing by 12? It's compounded what? Compounded monthly. Okay. Okay. Negative 2. 5 times 12. 5 times 12 is? Okay, so 5 times 12. Okay. And then divided by 0.1 or 12. Thank you. Okay. So what are we going to do? So how are we going to find X? So how are we going to manipulate the equation to find the value of X? Sorry? Okay, so we can divide by what? Actually, sorry. So times both sides by what? By 0. Okay, over 12. And divide by this, right? Okay, so it multiply by 0.1 over 12, and then 1 and divide by this. But I'm just going to quickly go to, I'll say x is equals to 30,000 divided by 1 minus 1 plus 0.1 divided by 12. Okay, so it's a 5 times 12 is what? Negative 60, right? Over 0.1 divided by 12. Okay, short way of. Right. Okay, the most direct way of actually getting to the answer. And x is equals to 637,41. Okay. Okay, thank you.
Six involves the outstanding balance. Okay, all right, Matthew, the point of message. Well, I told you a few years ago, but I'm not about to here. We'll see a lot of the example that is then we learn it for this the remember one demand person. But how do we know then we go?
I will prefer the open between.
Yeah, do you want to? Sorry? Yeah. So we're gonna say the outstanding balance, which will be represented by P, right, is equals to the formula, right? This formula. Okay. Now, what is the value of x? Okay, so we know that the monthly repayments are what? 637. Okay, so this is 637, 4. Okay. Right. Okay. 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 So 0, over 12. Okay. 54, 15, 12.
I'm telling you everything and I'm telling that. Yeah. Um. Does that make it always work? It doesn't. This is very clear. That method only works when we know exactly how many payments are being made. And we work out the payment. The outstanding balance will be the present value of the payments that have not been made. Yeah, that's actually not the payment of the journal. The other one, something to write down what I'm saying, maybe a bit of a kind of thing. OB equals. Check out. There you go, you got it. OB equals loan with interest minus payment made. with. So when I was around 50, you start there, okay? This money, this the five kind of value is just, I want you to write it in B, because that's the future value of those payments. Right. Now, if you wouldn't mind writing down, how much was the loan in the 3 years? 300,000, okay, so 30,000, so that's 30,000 there. 1 plus 0.1 over 12,
1 plus
open bracket,
also
1 plus 0.1 over 12. Over 12, sorry, 12. To the power of 24. Minus. Now, 637 or whatever, don't worry about that to the exact here, okay? A big square bracket. 1 plus 0.1 over 12
1 plus 0.1
over 12. To the 20 bracket, put brackets on. Yeah, no, no,
times. Sorry,
minus
minus 1.
0. Okay. Now, then, if you do that, that we are taking the loan with interest minus the payment made with interest. This always works. It's the same method. Okay. Like one method, and you did it very nicely with perfectly, as long as you know exactly how much payments are there. All right. Okay, we're going to stop for me. I don't even need to study the field. And then I'll teach you to help with the hanging out with the please don't take more than 1% story like that. Hopefully it's fresh because I want everybody until we have. Guys, we actually have 5 no. Okay, thank you.
Weird. It says that when Gabriel was. Yeah, you just hold it down. Yeah. Right. Thanks so much. That was excellent. Yeah.
Guys, it is 11 o'clock. So come in as quickly as you can and let's start. We actually did really, really well in the first half. We got through 77 marks of the 150, leaving us 73 to go. So we are well on track. But there is some stuff I want to talk about at the end as well. I want your help with something. So I want to show you some stuff. Right, come in as quickly as you can. Okay, there are quite a number of learners not back, but guys, I am going to start. All right, I'm going to ask Mr. Babaleka to see if he can find someone to help us with this question. We've got a car depreciating on the reducing balance. All right, and the first question, and it's quite a straightforward question, it just says, what will the depreciated value be 3 years after the purchase? I'm looking for a hand, I'm looking for a microphone, and I'm hoping that the microphone works. If not, we'll change the batteries. Is it on, Mr. Babaleka? The microphone, yeah, great, thank you. Right, take it away. Hold it nice and close to your mouth. I can't hear you, but hold it nice and close to your mouth, yeah. Okay, great, thank you. Talk nice and loud, please. Okay. Done. Sorry, guys, you're absolutely right. I'm going to ask you to read it to me again. I've just realized that the music is playing, which is not helping our cause at all. Okay, 10. 101,000. Okay. 230. Sorry, guys. 2 what? 3 0. Sorry. Okay. 5 0. So I actually cannot hear. Sorry. I don't know if it's yeah. Sorry. Okay. Thank you. Very well done. Thank you. Last answer. Right. Okay. Now, does the annual insurance premium, all right? The average increase. Now, guys, I'm going to do this one. All right. It became 1,260. All right. It was 1,200. Right. So the difference is 60. But that 60 must be out of the original premium. All right. And then how do we make this number into a percentage? At the moment, it's a decimal. Times by 100. All right. So in fact, that divides out. And I get 60 divided by 12. I get 5%. The premium went up by 5% in the first year. Right. Now the next question, and it's quite, the wording in this question worries me a little bit. It's not problematic, but it's quite, just going to read it carefully. The insurance cost is going to increase by the same percentage, 5% every year. After how many years will the insurance cost be more than the depreciated value of the car? Okay. Now, the depreciated value of the car, all right, remember the car is going to keep depreciating. Okay. And the insurance price is going to keep increasing. So the insurance price is going to be that much after N years. Am I right? Okay. I want to work out when that is equal to the depreciated value of the car. And if we look at the work that our friend did over here, it's basically 240,000 times 0.75 to the power of N. Okay. Now, sorry, man. Something went horribly wrong there. 240,000 times 0.75 to the power of N. Now, this question actually looks quite difficult, but who can tell me how could I get all my N's on one side? What could I do to both sides to get the N's on the same side? I could divide by 0.75 N. I'm just going to change that to 1.05 to the N. And this is 0.75 to the N. Okay. Right. Now, I'm going to divide both sides by 1,200. When you divide 240,000 by 1,200, what do you get? $100. Yeah. 200 or 2,000? 2,000. 200. Thanks. Okay. It's definitely, sorry guys, it's definitely 200. All right. I'm very tired and I'm now like, my brain's starting to freeze up. Okay. Now, Nancy Kinga, this is an interesting little thing here. Can anybody tell me how we can use our exponent laws to get the N into one place? I want someone to just put your hand up and talk nice and loud, even if you haven't got the microphone. Just tell me what I'm going to do. Introduce log, but the N's are in both places. Let's try and, okay, maybe I'm not making myself clear. If I do that, is everyone okay with that? That, guys, we know from our exponent law that if we've got a fraction, the numerator and the denominator get the power. Okay, now you're absolutely right. We're going to use log x. Okay, what I've done from here, from this line to the next line, is I've got my n's from being in two places to being in one place. And one place is always going to be better. Okay. Can you tell me, and just say it nice and loudly, you're close by here, so don't worry about the microphone. What will it be if I put it into log form? Base will be that, huh? So log base, remember guys, the base is always the base, eh? Of what is what? What am I going to write here? 200 or 200. There it is. Okay. And now I can go and find a calculator, hopefully. I don't know where I'm going to find a calculator, but I will find a calculator. How much? 2,91. Okay. Yeah, guys, I'm just looking for a normal screen here. Okay, I'm just trying to find a calculator. Sorry, guys. There it is. Okay, so log fraction 1,05, 0,75, 200. Oh my soul, 200. 15,75. All right. Now I think it says to, like, obviously that's where they'll be equal. Okay. Now remember that we must round up, yeah. So it'll be after 16. It does say after how many whole years. So after 16 years, the insurance premium will be more than the depreciated value of the car. It's quite a cool question. A friend of mine who works here made it up. Okay. All right. Now, onto some probability. Events A and B are mutually exclusive. Who can tell me, and maybe Mr. Babalega, I know it's exhausting, but maybe you can try and just find someone who's happy to take the microphone and tell me what that tells us if A and B are mutually exclusive. What do we know if A and B are mutually exclusive? It's a short answer. I don't want people shouting it out. I want someone to talk into the microphone. Okay, over here. Is it working or not? If it's not, come here and I'll put some more batteries in it. Yeah, come here. I think it's full gear. Is it okay? Means it's going to section. You're 100% right. Can you tell me what it means in terms of a probability of something? So I just want, if they're mutually exclusive, I'm not even looking at this. Okay, I'm not worried about this. I'm just reading this. If they're mutually exclusive, can anyone tell me what do I know about something about a probability? No. What will be the probability of A and B? 0. That's what I wanted. So maybe I wasn't clear. Okay. All right. That will be the probability of A and B. Now, guys, we get a formula at the back of this workbook. I'm sure you've seen there's a formula sheet, and there's only 2 formulas you get for probability. This is a very, very important formula. Okay. All right. Now they tell us that 3 times the probability of B is equal to the probability of A. What I'm going to do now is I'm going to write down, I know the probability of A or B. That is 0,63. Over here, I'm not going to write down probability of A and probability of B because I want as few variables as possible. Okay, so instead of writing probability of A, what should I write? 3 probability of B, halala, plus another probability of B. And what is this? 0. And that's why this is so important that you pick up on that. This is 0. Now, how many variables, guys? Variables are left in this equation. Ellie Lord, what? Okay, just 1. So we should be able to solve this. This is 0,63 is 4 lots of the probability of B. How much? What must I do to both sides? divide both sides by 4. Okay, I'm going to just bring up my calculator. 0.63 divide 4. And I get 0.1575. Norma, 15.75%. Okay. Now it's, oh no, it doesn't. Okay, I thought I was going to ask for something else. All right. This is what we call a contingency table. It's got 2 things happening here, and it's got 2 things happening here. And the first thing they ask us, and I'm hoping that even if you were in grade 8, you would be able to work out this question. Okay, what number goes here, guys? 1879, thank you. And what number has to go here? 678. 3898, thank you. Okay, all right, easy. Now it says, are these things independent or not? I would love for someone to tell me how to do it. I don't want the answer. I don't want whether they're independent or not. I want you to tell me, because look at this, guys. 5 marks, huh? All right. Can someone take the microphone and talk us through what we're going to do here? And I'm going to remind you of something. This. Probability of A and B is the same as multiplying them together. If that's true, then they are independent. If they are independent, that is true as well. So this arrow goes both ways. Okay, who can tell me something I could work out here? Someone with a microphone. Anyone, put your hand up. Don't be scared. I'll tell you what, I'll give you a fizzer. Okay, I'll tell you what, I'll give you 2 fizzers. Okay, I'll give you 2 fizzers. You don't have to get it right, you just got to try, yeah. Okay, so you're saying we're going to look at the probability of being an undergrad and receiving financial aid. Okay, so you've told me that. Tell me what will that be as a probability? Over. Okay, halal. You've made a choice of one thing, one intersection. Very, very nice. Now, what am I going to do next? And I'm going to scroll back down to this little formula here, because what you've effectively given it, you've worked that out. Now, what are you going to work out for us? Okay, so I'm going to, you're right, but I'm going to just write it with some probability notation. Probability of being an undergraduate multiplied by the probability of what? Well done, receiving financial aid. Okay. Okay, what's this probability of being an undergraduate? Okay. Well done, 8,120, guys. Those are the total undergraduates out of what? Times. Who received financial aid? Out of? Well done. Did you manage to work this out as a decimal? 0.39. And this one? What did you conclude? Say it loudly. Allah. Mr. Mamalega. Please put two fizzers. That is a brilliant answer, guys. All right. Just to reinforce for you, did you give 2? Yeah. Just to reinforce for you that, guys, you don't have to choose that option. You could choose postgraduates who are not receiving aid. Okay, you'll get different calculations, but you will get the same conclusion. Okay, right, onwards. Now, we've got this word hammerhead, okay? Okay, a hammerhead is a type of shark in the Sahara. All right, now, can anybody remember what must I do if I want to work out the number of arrangements? And I'm going to start with an easier example. How many arrangements can I make with the word cat? 3 factorial. And guys, just because I can, I'm going to write them down. What is 3 factorial? How much is it? 6. I'm going to write them down. There it is, cat. CTA, ATC, ACT. This one happens to be a word. TCA, TAC. 1, 2, 3, 4, 5, 6. Are there any more? No, there's 6. Does it make sense? It all, well done, halal. It always makes sense. Okay, right. Good one. Now we've got a little bit of a problem because we've got some repeated digits. What would it be if all these digits were different? 10 factorial, well done. Now, who can grab the microphone? And I'm going to get a fizzer, take a fizzer with you, and tell me what must I do to allow for the fact I want someone different. Otherwise I'm going to give all my fizzers to one person, maybe. What can I do to allow for the fact that there's some repeated letters here? What must I divide by? And I want a hand, because then you're going to get a fizzer. I want a hand and I want a microphone, guys. I don't want a whole lot of people. Back yourself. You're being paid. You're now a professional mathematician. You're getting a fizzer. Yeah. Or M. For E. And then 2 factorial for the H's. Allah, you've earned yourself a fizzer. All right. Okay, guys, those H's, there are 2 of them. Okay. All right. We can work this out, guys. This is 2 times 2 times 2 times 2, 2 to the power 4 is 16. 10 factorial. Shift factorial. Oh, there it is. I know. Okay, I'm going to do the bottom. I've done the bottom in my head. 16. 226,800. Okay, now find the probability that the letters R and D are next to each other. Now, how many R's are there? 1. And how many D's are there? 1. Okay, now what's the little conceptual trick when we want to keep 2 things together? Who can say it's just one word? 2 words. A rubber band. We're going to put a rubber band around those 2. Okay, now what I've got left here, I've got 2 H's, 2 A's, 2 M's, 2 E's, 1, 2, 4, 6, that's all my letters. Okay, now how many, remember this formula. This is the other probability formula you get given. The probability of something happening is the number of ways it can happen divided by the number of total things that can happen. This thing at the bottom here is what we call the sample space. Okay. Let's work out, and we know the sample space that we worked out over there, 226,800. How many ways can I arrange these letters? Okay. If I want unique arrangements. How many letters are there? How many letters are there? Guys, they're not 10, they're 9 now. Eh? 1, I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8. They're 9 letters. Now, what I've got to do is I've got to divide by 2 factorial again. 2 factorial, 2 factorial, 2 factorial. Those are because I can swap the m's and the e's around. Cordwa, this is not 100% correct. My answer, I need to multiply my answer by something here. You can tell me what it is. 2 factorial y. These 2 letters, wherever they are, guys, they could be wherever they are. They could even be like in here. They can swap. We can either have RD or DR. Okay, so let's get our final answer to this one now. Okay, I've got that number in my calculator. It's in answer already. You can see it's in answer. So let's work out the top. The top is going to be fraction 9 factorial times by 2 factorial. On the bottom, I'm going to do that 16 again myself in my head. And on the bottom here, I've got the answer, which is 226,800. And I get 1/5. What's 1/5 as a 20, as a percentage? 20. Okay. All right. Okay. Number 9. I'll ask Mr. Mabaleke if he can do this one. I'm going to walk around with some fizzles and I'm going to look for people with microphones.
Right.
Okay, guys, question 9A. Any volunteers? Okay, any volunteers for question 9A? R is equals to P1, which is, what's the answer? 3/2, okay? So it's a geometric sequence. Okay, so S, sorry? Can you repeat that? Oh, so Tn is equals to AR N1 over. Oh, sorry. AR to the N minus 1. Is 2, 4. Three over 2, okay? You're going to substitute? Okay, can you? Okay. So, what do I substitute here for Tn? $5 million, okay. Okay. 4 3/2. Here to the n minus 1. So we're trying to solve for n, okay? He used log, okay? Before I didn't. Okay, so what is 5 million divided by 4? 50. Okay. This is equals to 2 to the n minus 1, okay? Okay, so I'm going to use log here. So I'm going to say log of. So, okay. So 1,002, okay? Sorry. Okay. Is equals to n minus 1, okay? Minus 1. And yeah. Okay. Minus plus, so I need to plus 1 on both sides. So plus 1, that should give me n. Okay. Sorry. Yeah, already said n is equal to that. Okay, so what's the value of n? It's 35, comma what? 2. Okay, so have you answered the question? What is the question? Okay, what are we trying to determine? Yeah, so which? It will be what? 36. Okay. Yeah.
As if n came after a whole number, then put it in the for the geometry. Okay, that is it's the very big term, it's the first one I can say, well done, very, very nice. Okay, looking for anything you want about something when I have an answer. Have a answer, yeah. But I think I'll go on to.
The facing of
Yes.
G, I,
Okay, so what does this mean? Okay. Okay, so I write the first 3 terms in sequence in terms of what? In terms of G, okay? So 3G minus 3, okay? Yeah, sorry. Oh, sorry.
4G minus 3.
So you have 4G minus 3,
Then
5G minus 3. Yeah. So my last term will be 5G minus 3. Yeah. Solve for n. Okay, so how do you solve for n? So top number, okay, minus bottom number, okay, minus 3 plus 1, 3
for my SN. SN,
So you said Sn is equals to, okay, what up? Okay, so now n over 2, yeah. A plus n. A plus L. Okay. So 1,000 for Sn. Okay. It's 1,219. 23 over 2. Yes. Yeah. So 3G minus 3. Okay. Minus open bracket. So 25G minus 3. Okay.
much like for sites.
So multiplying by what? So multiplying by 2 over 2 is okay. 160 is equals to 106. Okay, 106. So 28 G minus 6. So 28G 1, 1, 2. 4. Okay.
Guys, this is the thing there. I understand that, but like, when you look at the protection now, we use the slightly different formula. We use the 2A plus N minus 1D, right? You don't actually get given, I don't think, I'm looking at the features of the day. Don't think you get given the A plus N formula on the formula sheet, but I might be wrong. It's not an easy one to turn, but it worked perfectly. Yeah, if you can't work it, you do it fine with all of them. Yeah, I know that you try to is all. Again, it's not what you keep it done. Carry on. Okay, that's great. Well done. Anyone want to talk to us about convergence? When did you make it to converge on the hand and also distribution, not just the, yeah, anybody manage to have this? I think we got it. Yeah. Yeah, what's that? Instead of jumping up and letting off that.
Yeah, so R. Okay. Greater than -1. Okay, so what does this mean? Okay, so R would be between. Yeah. Okay, so how do we find the value of R? Okay, so X minus 1 over 2. Oh. Oh, sorry. Okay. Sorry. Okay. And let's just read this. Okay, just repeat what you said. Okay. That's the variant of R. Okay. Yeah, divided by 2. X minus 1, yes, x minus 1. Okay, x minus 1. That's okay. Okay. X minus 1 over 2. Okay. Okay. So what do I have? Yeah. Yeah. Okay. Gonna add 1 on both sides. So what do I have? -1. Okay. And 3. Okay.
So first, up the river. Wait. You got it, I'm saying, I'm gonna make this lady, she got her friend to the question, and then she took off the second. Hey, when yeah, giving the. Yeah, there's a. This question is a little bit confusing. Okay, let's see, let's see what is everything. Okay, so what I want to draw down for as the formula for the nth term of arithmetic is Tn equals, right?
A.
Okay, n minus 1 dot D. Now, what that formula, that Tn minus 3 says is that, this is the book should be, okay? I want to put some numbers, so if A, and I'm looking to highlight that formula that Tn minus 2, to highlight that, yeah, that's right. Now, if N was 5 in that formula, what would it be? What would it look like? T5 minus T.
Oh, sorry. Yes, T5 minus.
T. Now, okay, so we need to think now. The gap between two terms is X. I want you to write down another one. If A was 17, it would be T17 minus T1, 13. The gap between two terms is X. What is D for this sequence?
Okay.
D will be 4 now. In this question, D will be 4. And that's not maybe that easy to see. But you see, the reason it's complicated is because of the action of the N and the N minus 2. You see what I did? I put numbers in there to try and hopefully make sense of it. And what I'm saying is that the gap between two terms is 8, and it's an analytical form. So the gap between each term must be 4. Okay. Now I think the question has become easier. Right. Do not tell me how we're going to use the other piece of information. I actually want you to do the question from here for me if you can. All right. Yeah, I'll go on the front here again. Okay. If there's someone else who's like to turn me, hasn't got a turn. Going. You're What are you gonna do about it, sir? Not about anything else.
I use my knowledge of everything. PN
Okay, so Tn.
one
So Tn plus Sn minus 1 is equals to Sn. So S23, yes,
is 24.
minus S22 is equals to T23. Okay,
Person five.
is equals to 5. Okay,
But I can now
my N, which is what, 23. Okay, yes,
for D, which was 4.
yeah,
Then from there, I use my PN equation.
okay.
From PN, I substituted 95.
Okay, so T23, okay, is equals to 95, okay,
Use 95 is equal to
okay. Oh, you're not, yeah. Okay, so 95 is equals to
A plus
A plus,
23.
so which is 22, eh? Yeah. Okay,
A plus
A plus 88. Okay. Yeah.
Right, that's a beautifully answered. To be honest, if I answered it, I wouldn't have answered it. Yeah, I tell you what, I would go to now use my SN formula. You know, your error communicator, around 1D, and I'm gonna put 23 in, and I'm gonna put 22 in. But what he picked is that obviously, remember what S23 means? It means the sum of all the first 23 terms. What does S22 mean? The sum of all the first 23 terms. The difference is the only one that's the bigger one and not the smaller one is it's only T23. So that understanding that T23 is not fast is massive and it actually becomes quite straightforward. Very, very hard. Right. Okay, so this is carry on. I'm like, I'm looking for volunteers. I'm looking for someone who can record it. Okay, and it's another thing to go. But I'm gonna want you to play how you would like, how you would like to do it. Okay, if I'd love for you, here we go.
Sorry, can you speak up?
Okay, there, the first of how to go is not simple.
Okay, so
I
so the translation is, so we need to shift f of x to the right by 3 units. Okay. Okay, so shift again f of x to the what? Up, right? Upwards. Okay. By 2 units. Okay. So the turning point is what? 1 is to -1. Okay. Okay, so the graph should be concave down.
Well done. You see, when the head is, when the next person is -3, it's going to be -3 -4. And that's -1 -4. You can move those two forward. Yeah. So if you move that -4, that -4 actually goes, if you move it, sorry, -1 -4, so it will go to 2 -2, like there, yeah, well, that's sure. So there, and then just go to roll around this way. Guys, I'm not going to be too strict on it next time, but they would definitely, if you draw an exponential graph, I use what it is. Okay, all right. Or if you draw a straight line, I use what it is. So, you must draw, let's go, move, 3 lines, 2 lines. What, can anybody tell me, that we don't have answers certainly for the exam, but what graph is that? If you look at that, what's the graph? Exponential. Has it been moved up? Yes, it has. How much should it move up? Guys, put it down by 3. So if it's advertised, it's not with 3. Okay, anyway, carry on. What is this going to look like? Yeah, yeah.
We're reflecting on the y-axis, okay? So how do I go about drawing this? Okay. Yeah, so it's gonna be some. Okay. Sorry? Put it where? Yeah. Yes. How do I draw it? So it goes like? Like this. Yeah. So I'm trying to.
Yes.
Yeah. Yeah.
Does you agree that your calculator is not the time solver frequency? No, that's not how fancy your calculator is. Okay, even if you don't, if you don't have that, still when you have to, it's going to solve it right. Not going to help you here. Right now. This is our function index. That's what, you can tell me what graph is going there, and I'm going to give you 5 choices. It's straight line, a further, a log graph, an exponential graph, forever. What is that? It's not an exponential. It's a log graph. How do I know the difference between a log graph and an exponential graph? Exponential graph is a horizontal exponent. Horizontal exponent. Log graph is not vertical axis. This is a log graph. It's actually being shifted 1 unit to the left. Okay, we don't need to do that. Who can tell me how are we going to work out where for the inverse if we got the function? What trick are we going to use? Anybody? Well, one for that. Yeah. How will we wake up? What? And I think really, I'll tell you guys, and that we want to go for really. Yeah. A reflection with what line could I reflect and find the inverse? Why is it what I actually do? We have to reflect this graph It does not lie there. Because that's where inverse is reflected to. Okay. Right. Guys, that draw, listen carefully, let's just look at that picture. What is the domain of X? X must be bigger than 1. So the range of the inverse will be y must be bigger than 1. Your input has to be a horizontal asymptote at y equals 1. Absolutely there. That's another leg. Yeah, the original graph, reference asymptote x equals 1, the inverse x is in y is changed. So, thank you, I've done a little bit of okay. All right. That line is y equals 1. Okay, now, what's the name of the x intercept? The x intercept of x. What is the x intercept of that function there? The single x. 2, 0. Zero, 2. Okay. I'm thinking another point there, 5, 1. This goes up probably 5, 1 on the original function.
5, 1.
Yeah, 5, 2, sorry, 5, 2. Where will that point go? 2, 5, where's 2, 5? There it is there, okay. All right. See if you can now voice that. That's another way down.
Yeah.
It's going to go uphill.
Okay.
It's going to go uphill from that asymptote. Right. Correct.
Yes, yes, yes.
Yeah. A little bit that remember that this curve is moving along the right on this side by this. This curve is another side. Very good. And so it can come down. The dark and soft is as a part.
So,
Now, don't forget it in 35. Okay, so 2, 5. 2, 5. Here's not good. Here's not good. Yep.
oh, two.
I'm doing the type of that. It's the first time.
Okay.
Correct, yeah, that's really it. I can. It's very well. Yeah, I. So that. Yes, like that. All right. Does any idea about how to work out how we're going to do this? It's not going to be
Okay. So how should the function y is equals to x squared plus 2x minus 4 should be translated to become this function? Okay, so how do we know which standard formula of a quadratic equation actually tells us, or is it better, gives us a clue on how a parabola has been shifted? Y is equals to and minus p squared plus what? Now this p and q, what do they represent? The turning point, right? Okay, so do you think it's appropriate for us to actually find the turning points of these two functions? Huh? Okay, so let's find the turning point of the first one. So we want to see how this function has been translated to actually get to this function. Okay, so let's find the turning point of this function. Okay, so how are we going to find the turning point of this function? We're going to complete a square. We're gonna. What can we do? The shorter way of finding the turning point. Sorry. We can find the first derivative, okay? And then, so what do we do with the first derivative? Equate it to 0, okay? Again, find the value of x. But now, what's the shorter way, guys? X is equals to made of b divided by what? So what does this formula give us? It's give us the x value of the what? Of the turning point, okay?
Okay, so
Okay, so
Right? Once you put that, you put it back into the three line. Ideally, the producer will find the derivative like we can do it, put it back in. You multiply, but. Complete the square. It's a important skill. If I'm gonna, I don't know what they're off, okay? So, okay. So, certain not why people. I think that is plus, leave it down in front of the bracket. Square minus 4. Now, I'm looking at that first graph. That's the one at the top, okay? This I put into the bracket, so that when I square it out, I get 2 yeah, what is the bracket? I'm putting that, okay, now, so if I'm on top, x plus 1 over 2, I get the x squared, I get the 2 next, what do I get just 1 to 3 before? I get a plus 1, you agree? At the back with numerator what? Minus 1. Is it, and now on the next line, just write 1 equals x plus 1 all squared minus 5. Is everyone okay? That's equation that we're now looking at the first down is exactly algebraically the same as the original equation. Okay, what's the turning point? Now the next for the top.
turning point.
Oh, it's a nice number here.
Oh, yeah.
TV is -1, -5. Now let's do the other one, trying to different kind of pen, and then to quickly complete the square on x squared minus x. Okay, it's gonna be x, I just bracket x minus. What will it be? Yeah, what? Yeah, square. With my son, everything was not working on, it's not like that. What is going inside the bracket? So that I get a 6 when I square it up. The 3, because remember it will double up from the outer and the inner term, doesn't make sense. It always makes sense. Okay. What is the track to make this equivalent to the one for x squared minus the x squared? Minus 9. That 9 is the c squared. Yeah. The final one x minus 3 all squared minus 1. What's the turning point? 3 -1. Okay, now that's the still more on the way around, but the one on the black one, how much I've changed the black one to become the blue one? How much I've changed it or not? And we're gonna even finish. How much I've moved the black one to become the blue one? Yeah. How much I've changed the black one to get that third one to become that third one? Four and 4. You agree, if you move that turning point 4 to the right, you go from -3, yes. And if you move it 4 up from -5, the one that you will come from 1. Okay. Well done. Okay, right, next person.
Functions.
Okay, let's be.
Yeah. Pretty functions.
Well, I'll put it for like, I'll put for the negative big in there. And I'm gonna earn it 30. Okay, now guys, this is an interpretation question. It's meant to be a little bit challenging. Who can tell me in English, in words, what does f dashed of naught mean? In other words, when you see f dashed of naught equals naught, what does that actually mean? Who can describe what that means? What does f prime tell us? About what? Well done. It tells us about gradient, okay? The gradient at naught, and that naught that I'm talking about is this naught. The gradient at naught is what? It's also naught. It's also 0. Okay. This 0 is this 0. Okay. So we know that this graph has a turning point of some sort at 0. Okay. We also know that it has a turning point at 2. Right. You can tell me, what does this here tell us about this graph? What does f of 2 equal 8 mean? It's a point. Well done. It means the point 2, 8 is on this graph. I'm going to draw it over here somewhere. There's 2, 8. All right. And we know that this graph turns at that point as well. We are also told that it increases between 0 and 2. Okay. In other words, between 0 and 2, it doesn't come downhill, it goes uphill. All right. So, guys, it's going to increase here. It turns here. But it also turns here. Okay, now my graph's not actually correct. I'll tell you why it's not correct. Who can tell me why it's not correct? What's the y-intercept of this graph, guys? When x is 0 as a point, what is y? Y is actually 0 as well. All right. This thing hasn't got a d value kind of at the back. So, in fact, I've drawn this graph, but I've actually drawn it sort of a little bit in the wrong place. It actually needs to look like this. Okay, I'm going to try and use my green one. Okay, and lo and behold, I've lost the whole thing. Okay, guys, it's going to look something like this. All right, I would get that full marks if I was marking this. It's not very neat, but it's definitely a cubic function. Okay, obviously, guys, if you go and draw an exponential graph here, you're not going to get any marks. If you draw a straight line graph, you're not going to get any marks. Who can just remind me, when I've got a cubic function, if I looked at 2 cubic functions, how would I know which one is which here? Just by looking, this one would have an a value of what, and this one would have an a value of what? Yeah, well then, guys, positive cubic graphs go uphill first and then downhill. If you've got a negative x cubes, however many x cubes, then the graph actually goes downhill first. Okay, in this case, guys, this a value would actually be negative. Okay, then it says solve for a and b. Okay, now, how are we going to solve for a and b? And what's the big deal, guys, when you ask to solve for 2 variables? Well done, simultaneous equations. Okay. Who can give me an equation using a and b? In other words, involving a and b. What? Yeah, anybody, just put your hand. Yeah, talk nice and loudly. Sorry, 3ax squared. Okay, so you're absolutely right. He's worked out the derivative, the derivative of this thing, yes. And then what? Okay, we equate our prime x to 0. So, and what are you going to put into it to get 0? 2. Guys, do you agree you could put 0 in as well, but that's not going to help you, because if you put 0 in, you're going to get 0 equals 0. If you put 2 in, what do you get? Well done. Well done. Okay, one variable, two equations. We need another equation. You want to carry on? Carry on if you can. Yeah. Yeah. Right. Guys, what my friend has done over here is he has used this point not into the derivative, but into the function. Does it make sense? Always makes sense. We've got two equations. Okay, tell me how you're going to go about solving them simultaneously.
So my first equation, I make a very quick.
Okay. All right. B is equal to negative 3a. Good. From here, B equals negative 3a. Good. Okay. What do I get? 8 equals. Okay, so it's going to be plus 4 lots. I'm just going to go slightly slower here. You're right. Yeah. So it becomes 8 equals. Yeah. Well done. My A is negative 2. Now, guys, before I even knew that this question was coming, remember I said here in this one, A is going to come out negative, and it did. Okay. Tell me what B is. Well done. By subbing in there. All right. Okay, very well done. So 2 or 3 spare fizzes. Some people in this room are going to end up with diabetes, I think, from too much sugar, but very nicely. Okay, right. Okay, guys, this question here. Show that this equation has got real and unequal roots. Now, what branch of maths are we talking about here? It's nature of roots. Well done. This little piece inside here is very important. Okay. Guys, when will I get real and unequal roots? What must delta be? Greater than 0. So I'm going to work out delta, which is b squared minus 4ac. Delta is going to be p squared minus 4 lots of a is 1, p is minus 2. So guys, I get delta equals p squared minus 4p plus 8. Now, I want to show that this is always positive. And there's a very clever little trick to show that it's always positive. Can I write it in the completed square form, guys? What must I put in here so that when I multiply this green stuff out, I get this red stuff? P minus what? 2. I've got the plus 8, but what must I adjust here? I must subtract 4, which comes from squaring the minus 2. Delta for this equation is p minus 2 all squared plus 4. Now, I'm going to highlight these things. I've got this pink thing over here, and I've got this blue thing over here. One actually is more beneficial, more informative, tells us more, the pink or the blue? The pink. Okay. All right. And there was no gender thing there. I wasn't trying to say pink's better or whatever. But guys, the pink one, actually, who can tell me about delta, looking at it at the pink representation of delta? What's the smallest value p minus 2 all squared plus 4 can ever have? It's actually bigger than or equal to 4. That's not all that important. What we've shown is that delta is bigger than 0. And if delta is bigger than 0, then I know that my roots are real and unequal. Okay. Right, we're on to, I think, what is maybe the last question. But there is some stuff I want us to sort of talk about before we wrap. Okay. Right now. Okay, guys, this is an interesting question to me because it's talking about similar triangles. This is paper 2 stuff. But it says similar triangles have their corresponding sides in proportion. Now, I don't know what they're talking about similar triangles here. Here's a rectangle. But guys, are we okay that this green triangle actually going to have, it's going to be similar to which triangle? To the big triangle. Okay. So it's going to be similar to the big triangle. Again, I'm going to draw the big triangle now as a sort of red triangle. It's quite a big red triangle. The green one and the red one are similar. That means that if I take a side out of one of them, it will be the same as taking the corresponding side out of the other one. Okay. Now, so if in the red triangle, I'm going to take the red base divided by the green base. And do you agree that that must be the same as if I take the red height divided by the green height? Are we okay with that? That is similar triangles. Okay, now what are these things do I know? What is the red base? It's 10. What's the green base? It's X. What's the red height? 8. And what is the green height? Now this is a little trickier. What will the green height be? %. Halala. Guys, the whole height is 8. This piece is Y. This piece here must be 8 minus Y. Okay, and what we've got now, and it's not easy, we've got an expression connecting X to Y in this question. Now, what it asked me is to get Y on its own. I'm going to get rid of the fractions here by multiplying both sides by X and both sides by 8 minus Y. I will actually get 10 times 8 minus Y equals 8 times what? X. I want to get Y on its own. This is just solving an equation. So let's get rid of the brackets. 80 minus 8, 80 minus 10Y equals 8X. I'm actually going to add 10. I'm not going to transpose anything. I'm going to add 10Y to both sides. And I'm going to subtract 8X from both sides. I want Y on its own. What's the last thing I should do to all the terms on both sides? Divide by 10. Y is actually 8 minus 0,8 X. Okay, and that, guys, that's quite hard, I think, for 3 marks. A friend of mine said this exam. I thought that was quite hard for 3 marks. It's right at the end, though. All right, then it says, show that the area of the rectangle can be expressed as that. Which rectangle, guys? This rectangle here. Now, your problem here, Nuts and Kinga, if you couldn't do part A, you actually can't do part B. All right. It might have been better to ask in A, to show why y equals 8 minus 0.8x. What's our area for a triangle? Half base times height. Now, I only want to use x's. So what's the base of my rectangle? Sorry, guys, this is a rectangle. Okay. What's the area of a rectangle? Base times height. Okay. What is the base of my rectangle? It's x of the rectangle. We're talking now about this rectangle. It's x. And its height is 8. It's y. Absolutely, it's y. But I don't want to use y. I'm going to use what I've worked out y to be. So it's x into 8 minus 0.8 x. Right. And this is actually 8x minus 0.8 x squared. And we should be comfortable that 0.8 is the same as 8 over 10. And 8 over 10 is the same as 4 over 5. Okay. Now, the question is not finished, unfortunately. It now says, what's the area that we can make with it? What's the rectangle with the greatest area? How do I get the maximum value of a function? I make the derivative equal to 0. So I'm going to take this a equals 8x minus 4/5 of x squared, and I'm going to differentiate it. You could call it a dashed, normal, you could call it dA dx. And what do I get? 8 minus 8 over 5, good. That 2 is coming down and multiplying by 4 over 5, 8 over 5, x. And I want this to equal 0. Let's add 8 over 5x to both sides. And let's now, and I really like the way someone worded it earlier, they said let's multiply both sides by the reciprocal of 8 over 5. When you multiply both sides by 8 over 5, sorry, the reciprocal of 8 over 5, we get over here, we just get x, and here we get 5. Okay, when you finish answering a question, check that you've finished. Okay, we haven't finished because it asks for the dimensions. Now, guys, if x is 5, here's a formula that relates x to y. So y will actually be 8 minus 0.8 times by 5. 0.8 times by 5 is 4. 8 minus 4 is 4. So our rectangle is actually 5 meters. I don't know if these meters or what are they? Centimeters. Thanks. Our rectangle is actually 5 centimeters by 4 centimeters. This is a branch of maths that people find quite difficult. All right. Now, guys,